Huh? Okay, here we go. Alrighty.
5, 4, 3, 2, 1.
In this little blank section right here, I want to quickly remind you of how Mrs. Bag Crumble probably taught you to multiply. Mrs. Bag Crumble probably said 2 times 3 is 1, 2, 3, and 2 groups of it.
Yes.
Right? She probably drew a rectangle. And then, as you went further, you probably spent a bit of time in probably about grade 6 talking about the area of a rectangle being 2 times 3 because 2 times 3 got you 6 in the middle. You guys have seen both of those constructions, yes? And in grade 9, Mr. Myers used that rectangle construction to show you multiplying a constant by a polynomial, right? So you are aware of this construction. And it's basically this. X times y equals z. So something times something gives you a product. And in a rectangle, it looks like this. The multiplier and the multiplicand, which are words you will never need to know, go on the outside, and the product lives in the middle. Okay? Everybody good? And we've seen that all the way along. 2 times 3. 1, 2, 3. 2 times 3 with the 6 in the middle. In a rectangle, width of 2, length of 3, area is 6. Right? In last section, width of 2, length of 4x, multiplier, multiplicand, answer in the middle. Cool? All right, so now you already know everything you need to know to do this with algebra tiles. How would we draw 2D? 2 bars. And since that's part of the question, it goes on the outside of the rectangle, yes? What's the other part of the question? 3D. So that goes on the outside of the rectangle out here. Correct? Everybody got it?
Yeah.
Now, this is 1, right? But it stretches all the way along here, doesn't it? So, oops. What do we really get? Got it? So here that 1 comes out here again, but it stretches all the way out here. Got it? And here, and here, and here, and here. So, what is the answer? 6D squared. Yeah? When there wasn't, no, we're getting to that, but there's a reason we're doing it, okay? If there was no D in one of these, numbers would go with numbers, right?
Right.
2 and 3 gave us 6. But now these are involved, so the letter has to change too. Got it?
Got it.
Okay. So, find this product. What is the 2 pieces of math, the 2 polynomials that are the multiplier and the multiplicand, the parts of the question? 3e is one part, so that must be one side of the rectangle. Yeah? 1, 2, 3. Yeah? And what then must be the other side of the rectangle? 4e minus 2. Okay. 1, 2, 3. Actually, I'm going to change it to this way, guys. I'm going to put my 4e minus 2 up here because I had more room across the page. Cool? There's my 3e, agreed? There's my 4e and my minus 2, yeah? Where does the answer live? In the middle. Well, there's a big one. Big, 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 big. For what? What does that give us? 12e squared. Now, 1, but what wins? Negative or positive?
Negative.
Negative wins. What do we get there?
Negative 6.
Minus 6e. Can everybody do it? Everybody can do it? With a rectangle? Okay. I'm going to choose to believe you. And we're going to come down here and we're going to do 1. Oh, what am I? Not we. You guys are going to do these 2. Go. What's the answer to the first one? 8f squared. Because you have the big guys. The second one?
Negative 6m squared plus 12.
Is everybody good? Okay. Now all of you already should have noticed the pattern, yes? A bar and a bar gets me squared. A bar and a single gets me a bar. And a single stays the same, right? And that makes sense, doesn't it? So everybody's cool with algebra tiles?
Yup.
Okay. Let's do it real with numbers. If I had this, don't write this down, 3x plus 2, what would you do? You would do the distributive property, and you would get 3x plus what? 6. Cool? All right. If I had this, 3 to the 1 times 3 to the 1, what would the answer be? 3 to the
1, 2.
to the 2, because you add the exponents. Cool? All right. What would happen if I had x to the 1 times x to the 1? That would be x to the 2. So everybody understands all the background. Now apply it to here. Does this look like something you know what to do with?
Yeah.
Yeah. Draw an arrow, write an answer. Numbers with numbers. What's 3 times 9? 27. What's x times x? X squared. Oh, okay. Draw an arrow, write a number. Numbers with numbers. Minus, what's 3 times 4? Any letter here? So does the letter change? No? Done. Got it? Okay, let's look at this one. Why did I write it all out? Because this one tricks kids every time. I did it on purpose. That's the right answer. I left it there on purpose because a great many of you forget what part of this. What here is going to screw you up? You forget to change the sign because of that negative. Okay? So I have the right answer there just to show you, but we're going to actually write it out as well. 6 times 7 is 42, but because there's a negative out in front, the sign changes. 42x squared. 6 times 5 is 30. No letter. The negative changes the sign. Would it matter if there was 7 terms in these brackets? No, we would just do it 7 times. Would the rules change? No. Rules are rules. What if I had something that looked like this? Over here, I'm going to do a C. 2x times 3x plus 3y. What do you think you do there? Start with what you know. What do you know, Perry? You're going to do 2 times 3 to get 6. And x times x to get x squared. Okay. Positive, because this is a positive out in front, so the sign doesn't change. Then what? To get 6. Now we're in trouble, aren't we? Just xy. Because they're not the same base. So we're done. It's easy, right? Looks totally different, but easy to do. Got it? Okay. Make it happen. What do I do here? So multiply and then get a number. Numbers with numbers, 28. Letters with letters, x squared. Right? Okay. Plus. Does it stay plus? Why? Because there's no negative at the front. 7 times 5, 35. Does the letter change? No, sir. What about this one? Negative 3s squared. Draw an arrow. Does the plus change? No, because there's no negative out in front. We're good, yeah? And finally, there's a negative out in front, so 9 times 4 is 36, r squared, but negative. And then this becomes positive. 9 times 5, 45. Does the letter change? No. Everybody cool?
Yeah.
Now, you've been with me long enough to know not to trust that much blank white space, right? Good. Try this one. Negative 6r squared times 3r minus 2. What's that going to be? That's not very fair. We'll start with just 6r. Forget the negative. Does it look different? A little bit. Does that mean the rules change? Of course not. What do you do with the numbers? Multiply to get 18. What do you do with the letters? We're multiplying, but they both have exponents. So what do we do? Add them. What's the exponent with r? 1. So what is it here? R cubed. You were right, Abaye. And then we do it again. Negative 12 r squared, because there's no r here, so the letter doesn't change. Everybody good? Okay, I think you're liars. We'll try a fifth one. negative 4x squared y times negative 5xy minus 6xy squared plus 4x squared y squared. Mr. Myers.
Nothing changes,
Of course nothing changes. Why, Riley?
because, it doesn't.
Because rules are rules. There's a negative out in front. So what does that do to all the signs? Change them. Numbers go with numbers. What's 4 times 5? 20 x cubed y squared plus 24 x cubed y cubed minus 16. Yep. Perfect. Okay, that's really a grade 10 question, but I want to make sure everybody's on board. The only thing we would do with that is we would write it in a different order, wouldn't we? What would be first? The 16x4, right? Because that's the highest degree. Okay, then it would be x3, y3, and then x3, y2. Everybody cool? Why did I show you a grade 10 question? Just to show you the rules never change, even though it looks different. Everybody good? That, no, because we haven't done divided by. That's multiply. Can everybody multiply?
Yeah.
All right. Move it along.
Perfect.
Okay. On this question up here in the white space, I want you to cross out that S in the denominator and do this question like we did in the last section. What's the answer going to be? I don't care how you do it. You can write it any way you want. Four S squared minus 3S. Right? That's what we did last block. Everyone can do it, yeah?
Yeah.
Now, no matter how you actually wrote it, what you did was negative 8 divided by negative 2, and then left the letters because there was no letter on the bottom. And then you did 6 divided by negative 2 and didn't change the letter, right? Doesn't matter what you actually wrote, that's what you did. Cool? Everyone agrees?
Yeah.
Okay, what changes here? Do you think anything changes? No. We start with this one. Negative 8s squared over negative 2s. What goes together? Numbers go with numbers. What's negative 8 divided by negative 2?
Negative
4.
Positive 4.
Oh,
And s squared divided by s, what's s's exponent?
1.
1. What do you do with exponents when the bases are the same? We're dividing, guys. 2 minus 1 is 1, so it's 4s. Then we had 6s over negative 2s. Numbers go with numbers. So what's that? Negative 3.
S.
No! Nothing. S to the 0, which is 1, so we don't write it. So it's done. Does everybody get it? Okay? Please notice that we have to know our exponent laws if we're going to do polynomials. Right? Because polynomials can have exponents. If we don't know our exponent laws, we're not going to be able to do polynomials. So what have I got here? I've got 12 over negative 6, because numbers go with numbers, and I've got a squared over a. Letters go with letters. What is 12 divided by negative 6? Negative 2. And a squared over a? Done. Easy peasy, right?
Lemon.
Okay. What about this one? What have I got first? 9b squared over 3b. And 3b over 3b. Numbers with numbers. What's that? 3. Letters with letters. B. What's that? 1 plus 1. Done. Everybody good?
Oh, I get it, okay.
Okay. What do I have here? Negative 14c squared over what? Negative 7c. And 21c and negative 7c. Numbers with numbers, letters with letters. Negative 14 divided by negative 7. Positive 2. C squared and C? C squared and C? C? C, C. 21 divided by 7? Negative 3. C over C? Gone. Not 0. 1. So it cancels out. Everybody good? Okay, I'm going to do 2 more because you've got blank space. One will be a very difficult grade 9 question. The other one will be a grade 10 question. Cool?
Yep.
All right. That's my very difficult grade 9 question. What's the answer? Again, you can write it out any way you want. If you can do it in your head, go ahead and do it in your head. But remember, if you get it wrong, I'm going to give you 0 on the test. If you don't show me work and you get the answer wrong, all I can give you is 0.
What happens if you show work you get wrong?
Then I find where you made a mistake, and I basically say you're about halfway through the question, I give you half mark.
What work is in the shoulder?
Right.
What?
What work is in the shoulder? It's just the answer.
No,
Right.
I know. For grade 9, it is often just the answer. But unfortunately, most of you can't get, a lot of you don't get it right. So, what is the first one going to be?
3x squared.
3x squared minus 2x minus 3. Good. Now let's do a grade 10 level question.
Yay.
Hey, we're opposite.
Yeah, we are in grade 10.
We're opposite.
Or not, not choosing that. So overall, so we're not.
They don't have it, right?
I have 57.
I'm
My
out.
teacher was
I'm looking for you.
plus I did math. Where'd you start? Oh, holy moly.
Holy.
I go.
Wait a minute. Negative 7. Because I care and I want you guys to get good.
Where's my...
Who's feeling strong? Well, I'm not going to give the answer yet, but Aiden has volunteered first. Aiden can go for it in a moment. That's okay, Craig. You're allowed to be confused with this. It's a grade 10 question, right? Stay cool. Do as much as you think you can, and then chill. Are we ready for Aiden to try? 1 second. Perry is checking things out.
1.
I hate it when people do that. It's like you can say that again, and they actually say it again.
That's just being dumb.
As opposed to what you just did, which was the height of intelligence.
I'm already like a 2-year-old.
I know. Because nobody's smarter than 2-year-olds. All right. You ready, Perry? Okay. Hit me, Aiden.
2ab squared.
Whoa!
What?
Negative
-2ab.
Negative 2
AB
a
squared.
b cubed. There's no b on the bottom, so the b's can't change.
B cubed.
Now what?
C.
No. C on top, C on the bottom. So they're
They're
gone.
gone. Okay.
Then,
Plus, no, negative 3a. No.
I got it.
A on the top, A on the bottom. They're gone.
So negative 3b.
3b
Subtract.
Minus 4.
No, positive.
plus 4
B. BC cubed. Squared.
squared.
Okay, I'm close.
Okay, Craig, how close were you?
I got more than half of it. Like, you just got to see by like the b cube, and then like not knowing what to do with it. Like,
Right, because there's no b on the bottom, so the b can't change. It's just like what we did on in the last section when we had something like this. 30x squared divided by 10. There's no x on the bottom, so the x squared can't change. Numbers go together. So that would have been 3x squared. So same thing here. If there's no letter that you're dealing with on the bottom, he doesn't change.
alright,
Okay? Everybody good?
yeah.
All right. No.
We don't have any.
Where's the end polynomial?
254. It actually starts on 255.
Oh, what liars. Mr. Myers, you lie.
4. Seven, 11, 12, 14, 16 ABC, and don't have to do that. Don't have to do that. Don't have to do that, but I want you to try 22. Now, guys, to do 22, you're going to have to think real carefully. Now, listen. It's 12:30. We're here until 1:10. Guys, listen up, please. Because I want to take a moment right now. I can stop the recording, though.